One of the biggest challenges with building a single-page application is making the app visible to search engines and link bots. Fortunately, with Angular Universal, we have a reliable package for rendering our apps on the server. Not only does this provide SEO, but it can also improve the initial page load speed. In today's video, you'll learn how to server-side render an Angular app, then deploy it to Google AppEngine or Firebase Cloud Functions. If you're new here, like and subscribe, and make sure to follow along with the full source code on Fireship.io. Let's start by talking about what server-side rendering is and when you would want to use it. In any normal JavaScript app, whether it be Angular, Vue, or React, you will provide the browser with a JavaScript bundle. Then the browser will parse that bundle of JavaScript and figure out how to render the HTML. That's a great way to build a modern web app because it will make the user experience feel very fast and responsive like a native app. But the problem is that a lot of bots out there don't execute JavaScript. So that means if somebody shares a deep link in your app and that link renders some kind of dynamic content, the only thing the bot will see is your initial index.html file. So the purpose of Angular Universal and server-side rendering is to offload some of this work to the server. So when the user first visits a deep link, they'll get some rendered HTML with the dynamic content already included. For example, the Twitter bot just wants to read the meta tags in the head of the document, so it's just going to grab that HTML and then not worry about executing any JavaScript on the page. When you have just a regular user, they'll get that same pre-rendered HTML, so this usually results in a faster initial page load. Then Angular's JavaScript will take over, so it'll behave just like a regular Angular app on subsequent navigations. In order to make this possible, we can't really use Firebase hosting directly because it's just a static host. We need an actual Node.js server to dynamically render the content when a page is requested. We have two good deployment options for a Firebase project, Google AppEngine and Firebase Cloud Functions. There are some trade-offs between the two, but I'll show you how to set up both of them in this video. And they can both be used on the free tier. I'm starting out from a brand new Angular 7 app, and the great thing about Universal is that there's a schematic, so we can simply add all the boilerplate to our project by running this command. ng add Universal Express Engine, and then specify the client project as your project name. That will create 5 new files in this project, so let's take a look at each one of those now. The first one is the Webpack server config, and its job is to package and compile the server.ts file. So let's jump into server.ts, and you'll see that this is our actual Express.js app. Express is a tool that can receive a web request and then send a response back to the browser. So Express will receive the initial request, Angular Universal will kick in and render the actual HTML, then Express will send that HTML as a response to the browser. You'll also see a main server.ts file, which is just the entry point into the server-side app, and it also has its own tsconfig. From there, we'll jump into the app directory, and you'll see we also have an app server module. It's basically just a wrapper around the app module, and at this point, you don't have to make any changes to any of these files. Once we get to the Firebase stuff, I'll show you exactly what needs to change and where. So let's go ahead and install Angular Fire and Firebase, and then we'll jump into the app module. You'll notice one change here, and that's that the browser module is now calling with server transition. That just allows the app to be rendered on the server and then transition into a normal Angular app after the initial page load. From there, you can import all of the Angular Fire stuff that you want to use in your project. None of this stuff is actually required for Angular Universal, but I'm just making the assumption that you have Firebase in your project because there's a few caveats that we'll look at later. That takes care of the initial setup. Now let's go into the package.json, and you'll see that the ng add command added a few new npm scripts to this file. The ones that you'll want to use primarily are build SSR and serve SSR. First, we'll build the app, and then we'll go ahead and serve it just to make sure everything is working at this point. Now, just a quick side note, I highly recommend using Node version 8.14 when working in your local development environment. That's the version used on GCP and Cloud Functions, and that's what I used to build this tutorial. After running the build command, you should see a dist directory, and inside of that, you should see a browser build and a server build, as well as a server.js file. At this point, our app doesn't really do anything, so I'm going to go ahead and generate a new component that represents the About page for this app. Then we'll have this page dynamically render its own meta tags, so it can be used with a Twitter card or any other social media site. If you run ng generate component, you'll probably get an error saying it's missing the module. You can fix that by adding flag m with app to your command. That happens because there's 2 modules in the app directory and it doesn't know which one to use. When it comes to SEO, you'll most likely want to set a title and some meta tags when this component is rendered. And Angular provides a couple of services for you to do that called title and meta. Then I'm going to create an object with just some static data, but you could also pull this data from the database. From there, we'll go ahead and inject our dependencies in the constructor. And then with title, we can just simply call set title and then pass the dynamic data to it. Then the meta service has an add tags method, which we can pass an array of multiple meta tags. You can learn how to format meta tags by going to the Open Graph docs or to Twitter or Facebook. But basically, Angular is just going to add these tags to the head of the document when this component is initialized. The one thing that is very important is that you use this service to set the meta tags and not do it manually on the document or window itself. For example, if we wanted to get the URL, it's tempting to call window location path name, but the window doesn't exist in Node.js, so this will result in an error when we try to server-side render the app. So when using Universal, you always want to keep that in mind and just try to avoid touching the DOM directly. So in order for this to be useful to us, we need to have this component loaded by the router. If we jump over to the app routing module, we can just set up a single path to about that loads the about component. At this point, you should be able to load the app in the browser just using ng-serve, and you should see the meta tags in the head of the document. So at this point, we have dynamic meta tags, but if we were to share this link on social media, we'd end up with something like this. And again, that's because the meta tags are rendered by the JavaScript. Now let's go ahead and serve this app with Universal, so the meta tags are rendered in advance. First run the build SSR command, after that's done run serve SSR. That will serve the app on localhost 4000, but if you're using Firebase in your project, you should end up with an error like this. That's because Firebase uses a few things in the DOM that are not available in Node by default, but we can easily fix that by just adding polyfills for them. First, install WebSockets and XHR2 into your development environment. From there, go into the server TS file, and then add these two lines to the very top of it. If you run the serve command again, it should work, but it'll still give you a couple of warnings. You can clear out these warnings by installing these packages, and that command is available in the full article. And anytime you make changes to this file, make sure to run the build SSR command first and then serve SSR after. At this point, you can go to localhost 4000, and your app should look and behave just like a normal Angular app. But you can validate that your server-side rendering is working by opening up the page source. This is how the page looks when it's served to the browser, so before any JavaScript is run. And you know it's working if you see your meta tags and your dynamic title in this HTML. Now we have a big decision to make. Do we deploy this to Google AppEngine or to Firebase Cloud Functions? On AppEngine, our project will become a containerized app, so it can be deployed on AppEngine or any other cloud. And there's a free tier for Node.js, and it will scale up automatically as needed, and the pricing works out to be around $25 per month per container. But they will auto-scale based on the traffic and demand, so that pricing will vary. AppEngine is also very easy to deploy too, so in my opinion, it's the better way to go in most cases. But it's also possible to deploy to Cloud Functions, which gives you a tighter integration with Firebase. And it's hard to do a direct price comparison, but I suspect Cloud Functions would be less expensive. Pricing is based on the number of invocations of the function, which is free up to 125,000 per month. So those are the trade-offs. Let's go ahead and deploy to AppEngine first. You need to have the Google Cloud command line tools installed, so you should be able to run the gcloud command, and then we'll create a file called app.yaml. The only line you need in this file is the runtime as Node.js 8, but you can also specify different scaling options here as well. When you deploy, it's going to be looking for the npm run start command, so you'll want to go into your package.json and have that point to the serve SSR command. From there, it's just a matter of running gcloud app deploy, and that will push the container to Google Cloud and start running it as a service. That should take a couple minutes, but when it's done, it will give you a URL, and when you go there, it should have the same exact app that we were looking at on localhost. And the nice thing about AppEngine is that we have this dashboard where we can look at the different versions, we can look at the debug logs, and we can even look at the source code. So that was super easy. Now let's take a look at Cloud Functions, which requires a few more steps. The first thing we'll want to do is run Firebase init for hosting and functions. I'm going to use TypeScript functions, but the process is almost identical for JavaScript functions. From there, go ahead and point to the dist browser directory, and you'll say yes to configuring the app as a single page app. We'll go ahead and configure it to rewrite all of the traffic to a cloud function instead of the index.html like it normally does. You can name this whatever you want, but I'll just go ahead and call it SSR. Now we need to cd into the functions directory, and we need a way to get our Angular code into our functions environment, because Universal needs that source code in the runtime to render the actual content. I'm going to write a little Node script here to handle that, and to make life a little bit easier, I'm installing File System Extra. Then we'll create a file called cp-angular.js. Now there are many different ways we can do this, but this is the way I chose to do it. Basically, we just have a function that will copy the files from the dist directory in Angular over to a dist folder in the functions directory. Then we'll also always want to remove the copied files on each new build of Cloud Functions just to make sure we're always working with the latest Angular code. From there, go into the package.json for functions and run node cp angular in your build command. And while we're in here, let's also set the engine to Node 8 so that it deploys our function as a Node 8 function. Now we'll go to the source index.ts and write the function itself. It's actually super easy. All we have to do is take the universal app and then pass it into an HTTP function. As you can see here, we're actually importing the Universal app from our current working directory. So that's why we have to copy it over to the functions environment. And that's all there is to the function side of things. But in order for this to work, we need to make a couple of tweaks to the original server code in Angular. Open up the server TS file and then add an export in front of the app variable. Then go all the way down to the bottom and comment out the listener. Cloud Functions is already doing the listening, so we don't want this line in our code. And we need to make sure that our code gets exported as a library that we can consume. So add library app and library target UMD. And if you have issues bundling, you may want to add Firebase as an external. Now it's time for the moment of truth. First, make sure to rebuild your app using the build SSR command in Angular, then go into the functions directory and run the build command there. From there, run Firebase serve, which will serve your hosting and your function simultaneously. Hopefully everything went well and you're seeing the rendered meta tags when you go to localhost 5000. If that's the case, go ahead and run Firebase deploy, and that will deploy the function and hosting, and now you have a fully server-side rendered app running on Firebase Cloud Functions. After it deploys, head over to the Twitter card validator just to make sure that everything is working as expected. I'm going to go ahead and wrap things up there. If you run into any issues, let me know in the comments or on Slack. Thanks for watching, and I will talk to you soon.